Before adding partitions to our cube design, we need to be clear on our partitioning strategy. To the end user, a cube looks like a single object, but if we have Enterprise Edition, we can manage the data in a cube as separate partitions. More accurately, each measure group in a cube is already in a separate partition, but we can create multiple partitions per measure group to achieve specific performance and management goals for a cube. Now, there are three main reasons why we break a measure group into separate partitions. First, we can use partitions to optimize storage. We can define different storage modes for each partition: molap, holap, and rollap, which affects how and whether data is stored on disk. We can also place the physical partition on different drives, or even on different servers to distribute disk I/O operations. We'll look more closely at molap, holap, and rollap storage modes shortly. We also use partitioning to optimize query performance. We can design partitions to control the contents of each partition. When a query can find all data in a single partition, it can retrieve that data more quickly. But even if the data is spread across multiple partitions, the partition scans can occur in parallel and occur much faster than a scan of a single large partition. In addition, we can set different aggregation levels for each partition, which can affect the amount of extra storage required to store aggregations, but it can also make queries run much faster. We also use partitioning to optimize processing. Often the data that gets loaded into a cube is not changing. That means we can load it once and leave it there. Processing is a topic that I introduced in the Analysis Services Fundamentals course, and I'll be discussing it in a little bit more detail later in this course. Processing is the mechanism that actually loads data into the cube's partitions. If we separate data into partitions, we can restrict processing to a single small partition to load current data and leave other unchanged data in place in separate partitions. That makes processing execute more quickly. Furthermore, even if we have to process multiple partitions, we can process them in parallel and thereby reduce the overall time required to process. The amount of parallelism that we can achieve depends on the server hardware that we use for analysis services. When we create a partitioning strategy, we can mix and match different storage modes, aggregation levels, and have a variable number of rows per partition. For example, we can have a couple of months' worth of data in the current year partition, 12 months in a prior year, and 5 years or 60 months in a history partition. Another benefit of this approach is the ability to maintain a moving window of data. We can easily drop off older data by removing a partition and add in new data without disrupting the existing data that we want to keep in the cube.